Okay, I think we can start now. So good afternoon, everybody. So last time I explained how can we program the LEDs. We have here 8 on the board. Here we have 8 LEDs. I explained how can we program them. I used one LED to make like a flashing LED. Turn it off for 1 second, off for on off. Okay, and I told you this flashing is actually a square wave. So all what you have to do here, you have to generate a square wave. And the way we generate a square wave is very easy. You just write a program. You pull the pin high with some time, pull it low with some time, and then repeat. And that's what we're going to do in the coming lab anyway. Okay, today I'm going to explain how can we use a buzzer. We have a buzzer here. By the way, if your board has a sticker like this one, please remove it, because with this sticker, I think it will be difficult to hear the sound. So we have a very simple device to make sound, very simple. We call it a buzzer. So today I'm going to explain how can we program this buzzer, okay? So number one, by the way, any device, I'm going to explain. Number one, I have to tell you how it is connected. Number two, how it works, and then how we program it, okay? So, by the way, I'm not going to follow the same. I'm not going to follow the same order of these slides. So I'm going to come back and explain the 7 segment. Don't worry. So I'm going to come back. So I want to teach first what we need for labs. Okay. So I'm going to come. Yes. We have a quiz tomorrow. No quiz tomorrow. Okay. The coming labs should be somehow long, take some time. So we're not going to have more quizzes, at least for now. Anyway, so let's see the buzzer. As you see here, guys, in this figure, the buzzer it's connected to only one pin, which is PT5. Okay, so this buzzer is connected to PT5. Okay, then the way now how I can generate a sound, how I can make a sound using this buzzer. Very simple. All what you have to do, guys. Can you see PT5? I told you before. PT5 means port T, pin number 5. Okay, all what you have to do, just on this pin, you have to generate a square wave. That's it? Yes, that's it. All what you have to do, just generate a square wave. However, what about the frequency? Can I make any frequency? No, not any. Why? Because our ears can only hear a certain range of frequencies, okay? Usually this certain range of frequencies between 200 hertz to 20k hertz. Okay, this is all human being can only hear this range of frequencies. Is that okay? However, as we get older, some frequencies we may not be able to hear. Okay, that's why there are some websites that try to make guess about your age, try to guess your age from the frequency you hear. So the website is going to generate some frequency. It's going to ask you, do you hear it? You answer yes or no, and then it can tell your age. Okay, can guess your range of age. Okay, children can hear more frequencies than us. I think in one semester we did like several frequencies. It was some kind of fun. We generated several frequencies, and then we found some people can hear some frequencies, others. But anyway, but for human being, usually you have to generate a frequency in this range. Outside this range, you are not going to be able to hear it. Okay, anyway, so you are telling us in order to make a sound, all what I have to do just to generate a square wave, and that's what I explained last time, so it shouldn't be difficult. But all what you have to do just to consider the correct frequency, and you know every frequency is going to make a tune. Okay, that's why by changing this frequency you're going to have a different tune. Okay, this is for the people. If you go to the YouTube channel, you will see some people did like some songs before using this buzzer, and the way you can do it, any song should have tunes. So by changing the tune, you can run a song. Okay, So, and the way you can change the tone, just change the frequency. That's it, very easy. Okay, now, I want to make a program right now. This program should make like alarm or a police siren or alarm, whatever you want to call it, alarm. In alarm, we should have two tones, okay? And then I'm going to alternate between these two tones, okay? That's why when you hear the alarm, you hear something like, So is one tone, is another tone, and so on. So every tone is frequencies. That's why in this program, I want to make alarm. That means I want to run this frequency for some time, and then I want to run this frequency for some time. So how can we do that? Very simple. I'm going to tell you how it is very simple. Let's see first. So I told you here, I have to generate a square wave. Okay, that's very easy. What is the frequency? The frequency is 250. When the frequency is 250, the period or the time should be 1 over the frequency. The time from here to here, okay? That means it should be 4 milliseconds. 1 over 250 should be 4 milliseconds. Is that okay? That means the delay here has to be 2 milliseconds, and the delay here has to be 2 milliseconds. Very easy. That means in order to generate this signal, you have to pull BT5 high. You have to, the delay 2 milliseconds, and then you have to also pull it low, delay 2 milliseconds. Very easy, right? Okay, what about this frequency? It's exactly the same thing, but I'm going to change the numbers. So now, for this frequency, the period should equal 1 over f, which should equal 2 milliseconds. That means I'm going to just change the delay. That's it. So the delay should be, because this is from here to here, should be 2 milliseconds. So this is 1 millisecond, 1 millisecond. Is that okay? So generating this frequency is very trivial. This is similar to what we did before. Pull high, wait some time, pull low, wait some time, and then that's it. And then by changing this time, by changing the delay time, I can generate different frequencies. Okay, that's okay. Now, until now, everything is easy, but the question is how I can alternate between the two frequencies, because I told you I want to run this frequency for half a second. Half a second, half a second, half a second, half a second, half a second. So I need to alternate between them half a second. So how I can do something like that? I'm going to tell you how. Look here, guys. For this frequency here, as we explained here, the period from here to here, the period is 4 milliseconds. Okay, so you can now think about it in half a second. This is half a second, half second. Half a second means 500 milliseconds. In 500 milliseconds, how many cycles I have to generate? How many cycles I have to generate here? Okay, given that every period here is 4 milliseconds. So I'm going to divide 500 milliseconds divided by 4 milliseconds, and the result should be what? 125, I guess. Whatever it is, 125. Okay. So now 125. That means what I'm going to do is I'm going to generate this frequency for how many times? For 125 cycles. Right? So I'm going to make iteration. I'm going to make a loop, for loop, right? Every iteration, I'm going to generate one cycle. So how many times I have to loop back? 125, because 125 is going to be half a second. Okay. After that, I'm going to switch to the other frequency, right? Let's do the same thing, calculations again, but for the other frequency. What I'm going to do right now, I'm going to just repeat the calculation. The only difference is, still I want to generate the other frequency. Still we have half a second. The only difference is this one is 2 milliseconds. So 2 milliseconds is here. Okay. So how many I have to generate? You can guess. The other one was 4 milliseconds. This time 2 milliseconds. That means I have to generate more, right? Because this is the time here is smaller time, shorter time. So it's going to be 500 divided 2 milliseconds. I think should be 250 cycles. So I'm going to loop 250 times. That's it. So let me tell you the conclusion. The conclusion is, before I choose a program, or before I tell you how can we program it, the conclusion is I'm going to make full loop. So I'm going to make full loop for 125 iterations. every iteration, I'm gonna generate 250 hertz frequency. Okay, this is and again the way you have to do it, just make the delay 2 milliseconds. That's it. And then after I finish this loop, I'm gonna make full loop for 250. Okay, and then to generate frequency 500 hertz. In every iteration, I'm gonna generate one cycle. Okay, so this part is gonna take half a second. This part is gonna take half a second, and then I'm gonna repeat again. So half a second, then repeat. Got what I'm saying? So now I'm gonna show you how I made it. Any question about the idea, the main idea? Very easy, very simple. So let's see how I made it. Okay, look here, guys. Number one, I told you before you use any port, you should configure this port input or output. Period. Only one time. You should one time at the beginning, because as I explained to you before, when you configure it, you are going to connect the hardware so that this port, that you connect the electronic circuit this way or that way to be input or output. So one time. That's exactly what I did here. Look here, guys. Here, very easy way, because this port is input or output. This port is output, because I'm going to send data to this port output, because it is output. So PT5, or sorry, pin number 5. Bit number 5 in DTRT. So in the register DDRT, you have pin 0, pin 1, all the way until pin 5. So this bit, I have to put 1 here so that I configure it output. And that's what I did here. Very easy. One time, should be one time, that's it. Any question? This is configuration. Any question? So now I configure BT5 as output. Okay. Number 2. Now, as I told you, all what I have to do, guys, I have to do for loop. That's what I did. Look here, guys. Forget this part. This is the body of 4. So forget it for now. This is the body of 4. So using this instruction here and this instruction, this is how I made full loop for 250 times. I'm gonna loop here 250 times. Chapter 2. Is that okay? In every iteration, I'm gonna generate one cycle in every iteration. Okay. So look now at the body. Try to see the body of 4. This part is the body of 4. Look here what I did. Number 1, you have to pull high. So bit number 5, you have to pull it high. Is that okay? Then you have to wait 1 millisecond. Then pull it low, and then wait 1 millisecond. So every cycle here, I'm going to generate. Every iteration, I'm going to generate one cycle as you see here. Is that okay? How many cycles I'm going to generate? 250, because I'm going to repeat this part 250 times. Any questions? This is the first tune. So this tune you can hear. Okay. After 250 cycles, which is half a second, I'm going to move to the other tune. The other tune is here. If you look at this code is identical, similar to this code. I just changed the numbers. Okay, again, this is the full loop. This is the body of full loop. Here, I'm gonna loop here. How many times? 125. So instead of using 250, I'm used 125. Okay. Number 2, instead of making the delay 1 millisecond, I'm gonna make it 2 milliseconds. Everything else is the same. So in every iteration, I'm gonna generate a signal like this one. Okay, and then I'm gonna loop 150. So that means I'm gonna spend, this is for one tune, guys. This part for one tune, and we're gonna spend half a second here, half a second. Also here, we're gonna spend half second here, half second here. And then I'm gonna go back to the beginning again. You see it? So every time here is gonna take 1 second, then go, 1 second, go, 1 second, and so on. Any questions? Easy, right? Very easy. Okay. Now, what if, and I'm going to leave it to the video, but what if, I'm going to choose a video now, but before I choose a video, what if I change these numbers? So these numbers, I made it half a second. What if I make it a quarter a second, something smaller or shorter? How make it different? For example, I'm going to make it a quarter a second, You know, sometimes the alarm can be more urgent. Like I'm gonna try to do it. Okay. So sometimes I will see it in the video, you'll understand it better. But if I make it like a shorter time, the alarm will be more urgent. Like, for example, this is a normal alarm. Normal alarm. If it is urgent, you get what I'm saying? Urgent. Why? Because alternating fast. So we'll see it in the video right now. Okay. Let me show the video first before we continue. Why it's not working here? What can I do here? Why is the sound? Why is the sound? Okay, let me close this one again. Okay. So let me, I'm sorry, let me. Okay, I'm gonna do it again. Yeah.
The styling program here, the tool is 250. Here, she is 250. And this one is 125.
So this is similar to what I explained. Okay. Half a second, half a second.
This one.
This is a normal one.
Now let's make the tone shorter. For example, instead of 250, I'm gonna make it 100. And as shown here, instead of 125 is gonna be 50. So now you will see the difference.
Okay, anyway, so very brilliant. I want to tell you something, guys. Number one, you have all the programs, you have the board, so you can try them, see if they are working or not. Okay. Sometimes I'm quite sure the programs you have, they are working. I'm quite sure. Sometimes when you run this program, it may not work for several reasons. It may not work. Again, the problem is not in the program. I'm quite sure the program is correct. Okay. For example, in some boards, I try to give you new boards. Most of you have new boards, should be okay. But just in case, sometimes the buzzer may be broken. Okay, that's why you don't hear a sound. Okay, or there is a jumper here. There is a jumper here. You should not play with this jumper because this jumper actually controls. I'm going to tell you just in case. So this jumper controls this buzzer. It's like a switch. This buzzer should get the signal from BT5 or should get it from analog to digital converter or from something else. So you can connect this with BT5 or you can connect this one or connect using the jumper. Anyway, you should not play in the jumpers, but just in case you can see here it is written, there is a jumper, it's written selection. You are going to select if the speaker is going to get from, you should not, the default, it should be connected to BT5, the jumper. I'm saying just in case it doesn't work, we can check the jumper, okay? Anyway, any questions? Now, I think in one exam, I asked the students, for example, if you have a security system, you enter like a pass. I want to open the door, so I'm gonna input, I'm gonna enter the passcode to open the door, and usually if the code is correct, you hear something sound to notify the person that the door is open. You hear something like beep, so it's not alarm, just one sound beep. That's it. So I think in one exam, I asked the student if the code is correct, generate this sound. It's only one tone. It's not two. Only one tone. Generate this tone. Only one tone for a certain 10 seconds or 5 seconds, something like that. Okay, it's the same idea like what I explained right now. Okay, for example, I told you. So if you want to generate the code for example, for 5 seconds, okay. So and for example, I'm going to generate this 500 hertz. So here every cycle should be 2 milliseconds. So how many cycles you have to generate in order to make it 5 seconds? As I told you, it should be 5 seconds. It means 5,000. So 5,000 divided by 2, right? 5,000 milliseconds divided by 2. So it should be 2,500, right? So you have to make loop for 2,500 iterations. Okay. Anyway, now I'm going to explain how I can do the same thing using C language. Any questions here before I go to C language? Okay. So in C language, guys, I'm going to do exactly the same thing, but I'm going to use the notation. I'm going to use the instructions of C language. For example, if I want to do something like that, I'm going to do the same thing for loop. I'm going to also do for loop. So I'm going to repeat exactly everything. I'm going to repeat it, but using the notation or the instructions of C, as you will see here. So number one, similar to what I did in assembly. Let me use here, guys. You should configure BT5 as output, right? Using this instruction. So as I told you before, if you wanna, so I have to do, this is DDR, this is DTRT, and this is pin number 5, okay? So I wanna put 1 here. In order to put 1, in order to write 1, you have to use OR, as I explained many times before. So here I used OR to put 1 here, and this is the number I have to use. Anyway, so this instruction here, guys, is exactly equivalent, similar to this one. Exactly, but this is as simple as this C. Okay, this is number 1. Number 2, here I'm gonna have infinite loop, as you see here. So I'm gonna have infinite loop here. So I'm gonna this part is exactly equivalent to this infinite loop here. Okay, now I want to make full loop 250, full loop 125. That's easy. That's what I did. Look here, guys. I'm gonna make full loop 250 and another full loop 125. Very easy. Okay. I just want to convince you nothing is new here. I just change the notation. I just change the instruction from assembly to C. That's it. So here I'm gonna make and then here this is the body of this for loop. In every iteration, I have to pull it high this way. So and then I have to wait 1 second. I have to pull it low and then wait 1 second and then repeat again. How can you pull high or low? Very easy. We don't have bit set and bit set and bit clear like assembly, but very easy. If you want to put 1, you use OR. If you want to put 0, you use AND, right? So that's why if you put here what I did here, I did use to OR. And then if you look at this one, should be 0, 0, 1, 0, and then 0, 0, 0, 0. This is 2, 2. That's why here this bit number 5 should be on. If you look at this one here, guys, this should be 1, 1, 1, 1, right? And then 1, 0, 1, 1. So here, 0, because I want to put 0 here. Anyway, I don't want to repeat it again. Again, nothing is new. This is exactly the same thing I explained also in chapter 2. How can you use logic operation to put 0 or 1? Okay, anyway. But here I use the assembly instruction. In assembly, in C instruction, this is OR, logic OR, this is logic AND. Is that okay? Same thing, if you look here, this part is again, it's exactly the same thing. But if you look here, I just use here 2 milliseconds, and that's it. Any questions? Okay, great. So now, so far I explained how can you program LEDs, which is an output device. I explained how can you program the buzzer, which is an output device.
Now I'm going to explain how can you program the switches. We have 80 switches here, as you see here, 80 switches. Okay, I'm going to explain how can you program them. Input device. So this is input device. Okay. So again, remember, if it is output device, you can send data to the output device. But for input, you cannot send. You can read from the input. You can say, for example, I cannot say load accumulator A, and then I put here output. It's wrong because I'm not gonna read from output, put it in A. If it is input device, yes, it's okay. You got what I'm saying? Anyway, so let's see. So here, as you see here on the board, guys, we have 80 switches. As you see, 80 switches, little, very small switches here, as you see here. Very small switches. Okay. These switches are connected to port H. Port H. Is that okay? So every pin, so port H should have 8 pins. Every pin is connected to one switch. Every pin is connected to one switch. Is that okay? And if the switch is open, there is a circuit here. I'm going to explain to you the circuit, but there is a circuit. This circuit is going to put here on the pin 5 volt if it is open, right? And as I told you, there is a connection, internal connection here somehow, and then you have PTH. This PTH is what we are going to use in programming. So every time there is 5 volt here, you are going to find 1 here. Is that okay? Same thing here. If you connect this switch, if the switch is connected here, so the hardware here, the circuit, the external circuit is going to put 0 volt here. Same thing here. This is logic 0. That's it. You got what I'm saying? So I'm going to explain the hardware. I'm going to explain how it is connected. But if you programming wise, nothing is new. All what you have to do, guys, as I explained to you before, number 1, you should program port H input 1 time. That's it. Number two, you have a byte, which is PTH. You have this byte. You can just check the bit. That's it. We did that all the time. Many times we did it in chapter 2. If you have a byte, how can you check some bits? If the bit is 0, that means the switch is connected, right? If the bit is 1, that means the switch is open. And then after you know if the switch is connected or not, you can do something. For example, as you will see right now, I'm going to use one switch, like turn on or off for a system. Turn on and off, okay? So I'm going to check the switch. If the switch, for example, connected, I'm going to consider connected is on, for example. So I'm going to turn the system on. If the switch is disconnected, I'm going to assume it is off. So I'm going to turn the system off and so on. You know what I'm saying? So you can use it the way you want to use it. But again, I just want to check the switch. And then after I know the switch is connected or not, I have to make action. I have to do something, right? Anyway, so now let's see how the hardware is connected here. Look, guys, forget this part for now because I'm going to explain it later. So forget this part for now, okay? So this is how the hardware is connected, guys. We have here 5 volt, as you see here, 5 volt. And we have here 100K resistance. We have here very small resistance. So this resistance, very, very small because this one is just 4. This one is 100. So it's almost, comparing to the 100, it's going to be almost short circuit. So let's see how it works. And this one is connected to the pin. This is a microcontroller connected to the pin. Let's see how it works. Look here, guys. If the switch is open, okay, very, very, very little current is going to come here because this is the input of a transistor. Very little current. So that means if this is 5 volt, almost there is no voltage drop here. So this one also would be 5 volt. You got what I'm saying? So it's like you have input here, and then this input is connected to resistance and send 5 volt. And the current here is almost there is no current. So this voltage should be close to 5 volt. Okay, that's why if the switch is open, this one is 5 volt. Okay, that is why when you read the corresponding bit, if the bit is 1, that means there is 5 volt. It means the switch is open. Okay. Again, it doesn't. I want to tell you, it doesn't need to be all the time. Logic 1, it means the switch is open. No, it becomes this way because the electronic circuit made it this way. The way I connected the electronic circuit is when the switch is open, you are going to put 5 volt. So it should be logic 1. You can connect the circuit in a different way. So that it doesn't matter, right? But you have to consider it in your program for sure. You can connect it in a certain way so that when the switch is open, you put 0 volt. Okay. So again, I'm talking about this design. Anyway, so let's see the other case. The other case is when you again, I told you forget this one for now. I'm going to explain it later. But now, if you connect the switch, so the current is going to go this way. Okay. And because this is a very small resistance, you are going to have here a very small voltage, very, very small voltage, like for example, 0.2, 0.3 voltage. Okay, so 0.2, 0.3 is going to be interpreted as logic 0. Because you know, logic 1 or logic 0 has a range of voltage. For example, from 0 to 0.3, for example, this should be logic 0. Or for example, from 4 to 5 volt can be logic 1. Anyway, so the current has to go this way. So again, the conclusion is, let me conclude it, very simple. So the conclusion is, number one, we have 80 switches. It's number one. Every switch is connected to one pin on port H. And then all what you have to do, BTH. BTH is a byte. And then you can just check bits. When I check bits, if I find that the bit is 0, that means the switch is connected. If it is 1, that means the corresponding bit is open. That's it. So now, programming-wise, the problem became, if you have a byte, how can you check some bits? And we did it many times. Okay. So now let's have 2 programs on this part quickly. So number one, you need to program port H as input, right? How can you do that? This is, you can do something like that. Move byte 0 to DTRH. Is that okay? So that means port H, DTRH should be 0, 0, 0, 0, 0. That means all the pins are input. Remember, 0 means input. Is that okay? You can, if necessary, you can say, for example, you can do it in a different way. You can say bit clear DDRH, comma, percent 11111111. So that means I want to clear all the bits. Yeah, this is okay. This is okay. Whatever you want. Okay. Any questions? Okay, great. So now what I want to do here in this program, this is just a very simple program. What I want to do here, guys, I want to read. I just want to see if it is working or not. So what I'm going to do here right now, I'm going to read port H. I'm going to send it to the LEDs, to port B. So what I want to do right now, I'm going to tell you why. Port H, I'm going to read port H. I'm going to send it to port B. Why? Because I want to see the values of port H on the LEDs. You got what I'm saying? That means if one bit here, if one bit is 0, that means the LED should be off, because I take from here, I send it there, right? That means one LED, every LED is gonna reflect, every LED is gonna reflect the status of the bit or the status of the switch, right? So if the switch is connected, so this bit is 0, so the LED is gonna be off. Okay. So anyway, I didn't like this logic. I didn't like the logic that if it is connected, it is off. I want to make it, if it is connected, no, make it on. That is why I'm gonna complement to port H before I send it to port B. So what I'm gonna do here, as you will see, number one, I'm gonna read port H, then I'm gonna complement it, then I'm gonna send it to port B. The reason I want to complement it, because if the switch is connected, I'm gonna get 0. I'm gonna make it 1. Then I'm gonna send it to the LED so that the LED turn on. So on means the switch is connected. You got it? So anyway, so let's see the program here. For the program here, guys, number one, all the ports you are gonna use, you should program them input or output. So number one, port H. This is for port H. Okay? As I explained before, I'm not gonna repeat it. As I explained before, we have here, when I use the LEDs, I have to program port B, I have to program port J, also I have to program port P for the 7 segment. Remember? Anyway, so this part just for the LED. So let me put this one. Only this one for port H. But this part and this part together for the LED, similar to what we did before. Okay? And now the program is here. The program is here. See what I did. I'm gonna read port H. Please don't be confused. When I read port H, it's gonna be similar to reading the memory location. You remember when you read the memory location, just put address and then you are gonna get the byte. That's exactly what I did here. So don't be confused when you see PTH. This is exactly similar to what you did before when you said something like load A1000. It's almost the same thing, right? So here, so I'm gonna read the byte from this location. I'm gonna put it in A. This byte, every bit should reflect the status of the switch. Is that okay? And then I'm gonna complement A, as I told you. Then I'm gonna send it to port B. Okay? I'm not gonna do it one time. I'm gonna keep repeating it. It's not only one time. Why? Why it's not only one time? Because anytime I want to change the status of the switch, I want to see it on the LEDs. That's why it's continuous all the time. Read, complement, send. Read, complement, send. So that's why every time when I connect the switch, we will see the LED on or off, as you will see in the video right now. Okay, any questions? I'm gonna say it again, guys. Look here. Because port H is input, I can read it, but I cannot write to it. It's input, makes sense, right? Because port B is output, I can write to it, but I cannot read it. This is one difference between ports and memory location. Because in memory location, I can read or write. But for ports, you either read or write, if input or output, which make more sense. Any questions? Okay, I'm gonna show you. Let me show you the video first before we continue. Yeah. So this is exactly the same program you will see right now, guys. Look here.
So if we look here in this program,
so all the switches are currently are disconnected. Okay, that's why all of them have 1 1 1 1 1, and when I complement, I put here 0 0 0 0. That's why all of them are off. You will see now when I turn the switches, what's gonna happen.
Now all the switches are off. That's why all the lights are off. When I turn one button on, look what happened to the associated LED.
So,
it's on now. Let me try to do all of them.
LED.
Look, all the lights are on, and so on. So if you any switch off, the corresponding LED is.
Okay, so now I'm gonna, I wanna teach how can we do the same thing in C, and you see most of the slides, I write the same program twice, one time in C, most of them, one in C, one in assembly, okay? So I wanna show again how I can do it in C. So in C, again, you have, you have to program here. You have to program port H as input, so I can write it this way. I can say DTRH equal to 0. That's it. That's it. So this one is exactly similar to the move instruction. This one or this one. Where is move? Yeah, this one is equivalent to this one. Okay. And then also I explained last time for the LEDs, you can use these two functions. As I explained last time, you can use these two functions in order to initialize the LEDs, or you can use, instead of these two functions, you can use all these instructions, whatever, the equivalent assembly, C of this instruction, as I explained before, okay? So you can use the function, whatever you like. So now what I did, these two functions should initialize the LEDs because I'm gonna use the LEDs, and this one should configure port H as input. Again, one time is enough. You don't need to put it inside the while loop. You don't need. You just, it's not a mistake, but why? You don't need it. Just one time should be okay. Anyway, and now, again, I have infinite loop here, infinite loop. In every iteration, what I do is, okay, so again, in C, I explain in C two different ways. If you want to do in functions, it's okay. If you want to do it like assembly, it's okay. So that's what I'm showing here. Look here, guys. So I can write port B is equal to the complement of PTH. So yeah, I can write this one. It's okay. You can do this one. Port B is equal to the complement of PTH. You can do this one. Or if you like functions, what you can do here, we have a function. We have a new function here. This function is called LEDs on, and then whatever you sent here to the function is gonna put it on port B. Again, if you like this one, I'm totally fine. If you wanna like this one, I'm totally fine. This is different from the function I took before. We had a function before, LED on, not LEDs, LED on. And this function, you have to send here a number. You have to number from 0 to 7 to tell me which LED you wanna turn on. This one is a different one. Here, this function is actually whatever you give me here, I'm gonna put it in port B. So port B is equal whatever you sent here. Again, so that's why here I'm gonna send as a complement of PTH. This is the argument I'm gonna send to the function. The function is gonna take this one and put it on port B. Okay, any questions? See, PTH means the byte at port H. But this sign here, this operator, as I explained before, it means complement. You flip the bits. Okay. Any questions? Okay. Now I'm gonna teach an interesting program, very interesting program. So now I'm gonna repeat the alarm program again. The alarm program I have just taught right now. I'm gonna repeat the alarm program now. However, I'm gonna make a switch. I want to use one switch to turn the alarm on and off. You get what I'm saying? So if I connect the switch, the alarm is on. I can hear the alarm. Okay. So if you disconnect the switch, okay, so the alarm is off. You turn the alarm off. Okay. So I want to use one switch from here to turn the alarm on or off. Okay. I'm going to show how I made it. Very interesting. Look how I made it. This is the program I have just taught right now. If you remember, this is the full loop. You remember the full loop 250? I told you I have two parts. This is one part, and this is the other part. Here I'm gonna loop 250 times. So this is exactly same program. I didn't change anything. All what I'm gonna do here, I just added this line, only one line. That's it. So this is exactly same program I taught before for the alarm. But I just added one line in the beginning. Let's see what this line is about. Look here. In this line, I'm going to say, branch if clear, the first bit. So if the first bit is clear, so here, this is PTH. In PTH, I'm going to look at the first bit number 0, okay? If this bit is 0, I'm going to assume 0 means whatever connected or disconnected, I don't care about. So I'm going to assume 0 means, because look here, I know this may be confused some students. A switch has two positions. Okay, one position you can consider it. Forget connected or disconnected. The switch has two positions. So I can consider one position on, the other one is off. Or you can consider the other one is off or this one is on, whatever you like. Okay, so it just has two positions. In your program, you can define this position on, this position off. And it's very easy. So here I assume if the switch is connected, whatever connected or not, but if I can find 0 here, so 0 means alarm should be off. I should not hear alarm. Okay. Again, if you don't like it, you can switch the logic. Easy. You can switch the logic. You can make it 1 instead of 0. That's very easy. So anyway, and if it is 1, I'm gonna make it on. 1 means on, 0 means off. I just want to do this one. Look what I did is I told you guys it's exactly the same program I taught before about the alarm. I just added 2 lines. I added this line here to configure port. I'm sorry, not this one. This one. I added this one to configure port H as input. Also, I added here this check. I make it check here. Look at the check. This is check. What I did here, guys, as you see here, if the first bit is 0, the system should be off. So I'm gonna keep looping here. So keep looping here. So if the system is off, keep looping here. Please don't come here. And if I don't come here, you are not gonna hear a sound. There is no sound. So as long as here you keep looping here, as long as the switch is clear, or sorry, as long as this bit is clear, so I'm gonna keep looping here. Is that okay, guys? If not, so I'm gonna come here for half a second, here for half a second, and then I'm gonna come back to check here. We have infinite loop. I'm gonna spin here half a second, and then I'm gonna come back here to check. That means I'm gonna check every 1 second. Is that okay? So every 1 second, I'm gonna come here to check. If this one is 1, if the bit is 1, so the branch should not be taken and have to come this way. You see it? Any questions? Okay, so I'm gonna check every second, because I'm gonna spin here half a second, here half a second, and then I'm gonna loop back to check. So if you change the status of the switch here in this 1 second, I'm not gonna you're gonna still keep running, right? So for example here, I'm gonna check here, and then after 1 second, I'm gonna check again. Okay, so if you turn the system off here, you're gonna have to wait sometimes until it off. It's not gonna turn on or off. It's not gonna turn off exactly at the same time. You answer what I'm saying? For turning on, it's gonna be at the same time exactly because I'm looping here. Once you turn it on, so there is no delay. I'm gonna come right away here. You got what I'm saying? So for turning on, there is no delay. But for turning off, there may be some delay, right? Which is less than a second. So, okay. So, and that's what you should observe in the video. I'm gonna choose now the video. You should notice when I turn on, it's gonna turn on immediately, no delay. But when I turn off, you will see there is, for sure, it's hard. Sometimes it's just 1 second. So, so there is a delay, half a second, still a little bit, but you can notice it. Anyway, any questions? So very simple. So all what I did, I added this line here. By this way, I just modified the program I taught before so that I can add a switch to turn the alarm on or off. Any questions? So here guys, I'm gonna check this bit. If this bit is 0, I'm not gonna come here to run the buzzer. I'm not gonna run the buzzer. I'm gonna keep looping here. I'm gonna wait here. I'm gonna keep waiting. I'm gonna keep waiting here until you turn the switch on, so that I'm gonna come here. Okay. Let's see before. Yeah. Before I show. Let's see the video before I show the C language.
So let's run this program. Look here, the siren is working. Now it's off. So here I'm gonna use the first button as on-off button. Look. Look, sometimes there is very little delay because we check the status of the switch every 1 second. Look.
This is not a weakness. Again, it depends on the application, and there are different ways to do the things. If you think this delay is it may be a big deal in some application, so you have to do it in a different way. That's why I'm going to teach another topics, interrupts and other topics. But now, yeah, in this application, it should be okay. If you turn it off and it's gonna last for 1 second or half a second, it's not a big deal, I guess. Okay. Anyway, so now I'm gonna teach how can you do the same program in C language. right now. It's exactly the same thing. So look here, guys. So again, this is a program I taught before. This is a siren program I taught before. Okay, we have infinite loop as you see here. It's exactly the same program I taught before. All what I did, I just added if statement here. That's it. So all the change I did, I did two changes. Okay, number one, I have to do this one as you see here. Okay, in order to configure port H as input. Number two, I just add if statement. Okay, so see what I did here in the if statement, guys. In this if statement, here, forget this one for now. What I did, PTH. So here I'm gonna PTH and 1. So here, this is how can you check. So here I'm checking the first bit in PTH. So PTH, I'm gonna do AND, logic AND, and the result should be P0, right? And then 0, 0, 0, 0, 0, okay? And then if this result equal to 1, if this byte is equal to 1, that means the bit is 1. Otherwise, the bit is 0. Okay, as I did it many times. Anyway, so PTH here, I do AND, logic AND to check one bit this way. Okay. Again, some people like to use functions. So here we have a function. This function is called the switch 1 DIB. So this function actually is going to return PTH. That's it. Again, why? Why you don't just use PTH? Again, because sometimes in C language, I want to hide the details. I don't even want you to know what ports we have. Just use the function. The function is going to give you the switch, the status of the switch. That's why, again, if you want to use this one, I'm totally fine. If you want to use this one, I'm totally fine. Okay. This is the whole switches here. We call it switch 1. So switch 1 is the whole, the eight switches. We call them switch 1. Okay. Anyway, so here, this is a function you can use. A switch 1 underscore DIB. This one should return PTH. If you want to just write PTH, I'm totally fine. No problem. Any questions? Very easy, right? Or any questions? Okay. Now, I want to explain also, we have here RGB LED. So let me see what I did here. So what I did so far, guys, I explained LEDs. How can you program the LEDs? I explained how can you program the buzzer. How can you program the switches? And I give you one program. How can you use the switches and the buzzer together? Is that okay? So now I want to explain. We have here, unfortunately, it's not sure. It's not. This is a very old version. It doesn't have what we call RGB LED, as you see here, RGB LED. But the ports you have, it has it, as you see here. So I'm gonna explain what is this, what is RGB LED, and how can we use it, okay? So and how this one is different from the LED we programmed for these LEDs. These LEDs here, guys, give you only one color. These LEDs give you only one color. If it is on, give you only one color. However, these are RGB LED, R for red, G for green, B for blue. So this is one LED, but can give you one of three colors. It can give you red or green or blue. Is that okay? So internally, how it is connected, look here. So internally, inside this chip, there are actually 3 LEDs, as you see here, 3 LEDs. That's why this chip should have three pins this way, or 3 inputs this way. So one input is connected to PP4, another one is connected to PP5, another one is connected to PP6. You get what I'm saying? So you have 3 input, one input for each color. You get what I'm saying? And all of them are connected to ground. So it is like you have 3 LEDs, as you see here, with different colors, red, green, blue. All of them already connected to ground. So all what you have to do, guys, very easy. So now a problem became, I have 3 pins. I have 3 pins here, BB4, BB5, BB6. That's it. If you want to turn the LED on, for example, I want to turn it red. So I should put here 1 or 5 volt, whatever you call it, 0, 0. So if I put 1 in PP4, so I turn the red on, and then 0, 0. Or if you want to turn it blue, I'm going to put here 1, and then you put here 0s. Very easy. So now it became, you have 3 pins. 1 pin, you put 1 in 1 pin and 0s in the other pins. Okay? That's how you can make it different colors. So also here, if you want to make it clear, you can just put 1 here, and then you can put 0 and 0 here, and so on. Okay, guys? Very simple. Look here. I was playing. I love the topic. That's why I was just playing. This LED is not designed to mix colors. This LED is not designed to mix colors. Okay? It is designed to give only 1 color. That's why if you want to use it correctly, only one pin should be 1 at a time. Okay? But I just was playing. So what happens if I put here 1 and 1? Yeah, you are gonna see some color between red and the blue, but the mixing is not very nice. Okay, but both of them are gonna turn on, and you're not gonna damage the RGB, right? But anyway, it shouldn't be used this way. The way it should be used, you should turn here 1 of 3 colors. Okay. Someone can ask me, okay, number 1, let me summarize what I said. It's 1 device. This device is connected to 3 pins. Okay, 3 pins. 1 pin should turn 1 color. So now the problem became, you have 3 pins. 1 pin should be 1, and the other pins should be 0. Very easy. How can you put 1 or 0 in a pin? That's what we have been doing for a while. Okay, so it should be easy. So now I want to talk about application, how something like that can be useful. For sure, there are several applications. Maybe I'm gonna explain one application here. For example, if you have a machine, if you have a system, I'm gonna give you one example. For example, guys, if I have a container here, and you have a liquid, you control, you pour a liquid here, and you control it somehow using a valve. You control this liquid, and now we have 3 cases. Either the liquid is below threshold, or for example, I'm going to have threshold 1 or threshold 2, right? So now the container should have 1 of 3 cases. Number 1, if the liquid is greater than T1, this is 1 case. Number 2, if the liquid is less than T2. Number 3, if the liquid between less than T1 but greater than T2. Okay, so again, I'm just giving you one example, but you can use the same example in any other application. There are three different states, and you want to shoot the people what is the state right now. Okay, so in this case, I can use RGB in this case, RGB. Okay, so for example, I'm going to say if in this case, I'm going to turn it red. In this case, I'm going to turn it green. In this case, I'm going to turn it blue. So that the operator of the machine, I can just look at the color. From the color, I can know what is the status. Okay. By the way, I'm not sure if you noticed it or not. We have some water fountains here. And these water fountains, they tell you the status of the filter, right? But they don't use one LED. They use 3 LEDs to tell you the state. It's the same thing. So I can use 1 LED to tell you the status of the filter. Okay. If you have to change the filter immediately, so I can make it red, right? So now, or I can make it green, whatever. Okay. So anyway, so any questions? You can think about again. This device should give you 1 of 3 colors, and it's up to you. You can define what each color means, right? And this is in any application, you can do this way. Also, how can you program it? Very trivial, as you will see right now, very, very easy. All what we have PP4, I guess, right? PP5 and PP6. Number 1, I have to configure these 3 bits output, right? Output, that's number 1. Number 2, if I want to turn this color on, so I have to put here 1, and I have to make sure I put 0 here, right? If I want to turn this one on, so I have to put here 1 and put 0 here, and so on. Is that okay? Remember, we used to port B before. We used to port B before. You remember how we used to port B before? So port B, okay? We used PP0 until PP3. Every bit of this one is used as enable or disable for each 7 segment. I didn't teach the 7 segment yet, but when the time comes, I already explained before, but when the time comes, you'll understand it better. Every 7 segment here has 1 bit to enable or disable it. Okay, like LEDs, like BG1 for LEDs. Now, in addition to this part, now I explain how can we use PP4 until PP6. Okay, so now I'm going to choose a program. What I want to do here in this program is, as you will see in the video as well, what I want to do in this program, I want to use the switches and also the RGB LED together. So what I want to do here, guys, is going to be one switch. I want to use one switch for each color. Okay, that means here I'm going to use 3 switches. If I connect this switch, so the red should be on, or if I disconnect, so the red should be off. So here, every switch should control 1 color. So all what I'm going to do, guys, I'm going to read the status of the switches, and based on the value of the status of the switches, I'm going to write some values here on these 4 bits. 3 bits. Okay, 3 bits, as you will see right now. So what I want to do, guys, again, I have 3 switches. Every switch turn on and off 1 color. Okay, so that's why you will see right now in the video as well. What happens when I turn on 2 colors or 3 colors? Again, this device is not designed for that. It's not designed to mix colors, right? That's why the mixing is not going to be very nice or very fancy, but it's designed to have different colors. Okay, anyway, so let's see the program here. Look here, guys. Number 1, because I'm using port H, you need to configure port H's output. 1 time is enough. Number 1. Number 2, because I'm using a port P, so I have to configure these four pins as output. You got what I'm saying? As you see here, you can do move. You know what I did here? This is 7 is 1 1 1 0 and then 0 0 0. So you put it to port B. Okay. Again, I don't care about the 4 pins because I don't need them here in this program. But you have to be careful. If I use, I think we had this problem before. If I use 7 segment, also I'm using the RGB, so I have to be careful because any change I make in the first 4 bits or pins on port P, it's going to have impact on. Okay. Here I'm not using the 7 segment, so it doesn't matter for me, whatever. So anyway, if you want to use move is easy to use, but you have to be careful when you use it, okay? Because move is going to change everything, right? Maybe if you want to be on the safe side, you can use bit set, bit clear, okay? So for example, here I can say bit clear, bit set, because I want to set or clear. I want to make it output, so it should be set, right? So bit set, DTRP, and then I'm going to use here 70, I guess, or you can like 0 1 1 1 0 0 0 0. So I'm going to change these 3 bits. Okay, bit set for these 3 bits. Okay, anyway, so now let's see how I. So now I did the configuration 1 time, and that's it. Now let's see how I made this program. Look at the logic here, guys. Here, look here, guys. I'm gonna check. This one here, I'm gonna check the first bit. If the first bit is clear, is 0, that means go to green. So that means, so now I told you I have, this is for port H. So I'm gonna use three switches. The first switch should be for green, to turn the green on or off. Okay, so now if the switch is connected, if this switch is connected, as I told you, I'm gonna get here 0. So 0 means I want to turn on, as you see here. So I'm gonna check this, the first switch. If the first switch is connected, that means I have to turn the green on. So that's why I'm gonna come here to turn the green on. You can see it. So if the first switch is 0 or connected, please come here to turn the green on. In order to turn the green on, I told you this should be PP watt, because this is 0, 0, 0, 0, and then we have here 0, 0, 1, 0. So this PP6. So here I'm gonna put 1 in PP6 because this is the green. I'm gonna turn the green on. Okay, guys. If not, if the first switch is disconnected, so now I have to turn the green off, and that's what I did here. I turn the green off. Okay, so this is again, this is very easy. This is just one instruction to put 1 or 0 to turn the green on or off. Okay, and then I'm gonna come here to check the blue. Okay, so this part of code is for green, which is actually you check the first switch. I'm gonna repeat everything again, but I'm gonna check the second switch. I'm gonna repeat again to check the third switch. Every switch should control one color. So now if I go to blue, so now instead I'm gonna just repeat the same code. The only change I'm gonna make, instead of 0, I'm gonna make 2. Why? Because here I wanna check, instead this one should be 1, 0, 0, 0, 0, 0. This one should be 0, 1, 0, 0, 0, because I wanna check this is switch. Okay. So now if this switch is connected, the second switch here is connected. So please go to blue. In the blue here, I'm gonna turn the blue on. You turn the blue on by just putting 1 here. Okay, that's why the number is 20. This is 20. Okay. If not, I'm gonna come to this way to put 0 to turn the blue off. Okay, so I check the switch. If the switch is 0, it connected, so I have to come here to turn the green, to turn the blue on. Otherwise, turn the blue off. Again, now the last one here, I'm gonna check this switch. Okay, that's why here I'm gonna put 4. 4 again is 0, 0, 1, 0, 0, 0, 0. So I want to check this bit, right? If this bit is 0, so I'm gonna come here to red. In red, so here this is port P. I'm gonna put the 1 here, and this is 0. I'm gonna put the 1 here, as you see here. If not, so it's gonna be a bit clear, this one. And then I'm gonna keep repeating. It's not only one time, I'm gonna keep repeating. So that this is how the program should work. We have 3 switches here. Every switch should turn on and off one color. Very easy. At any time when I connect the switch, I turn the color on. At any time when I turn it off, so this color is off. You will see I was playing. So you will see the video right now. I can turn the 2 colors together, 3 colors together, and see what's gonna happen. Okay, but again, as I told you, it's not very nice. But I'm gonna choose the video now. I don't remember which video. I have to, but let me which one. I will try both of them. I think this is green, blue, red. You have all these programs. You can try it at home. Okay. I think the other video is better than this one. I will see. I think the other video is better. I think there is also a jumper. There is a jumper that controls the operation of the RGB, I guess. So if it doesn't work, let me know and we can check the jumper. I think this video is better. So look here, guys. I'm gonna turn. Now I turn 1 switch, the first switch. Okay, when I turn to the first switch, should be green. The first one was green, right? The camera is not that good, but you can do it at home and see. This is green, just green. I tried to mix colors, but it's not designed for that. Anyway. Any question, guys? Okay. Okay. So now I explain. I'm done with REDs. I'm done with the switches. I'm done with the buzzer. I'm done with RGB, LED, right? Very easy. The RGB is just just 3 pins. You put one, you turn one color on. That's it. Very easy. And for the switches, nothing programming wise. I didn't teach any new programming. I apply what I did in chapter 2, right? So if you want to know if the switch is connected, you have a byte, just check the bits. Okay. If you want to turn the one LED on, just you have a byte, you put one in one bit, don't choose the other bits. Okay. Anyway, so now as I told you, I'm not gonna follow the same order I have here in the slides, but I'm gonna teach everything, but I want to cover what we need in the labs first. That's why I'm gonna jump now to the keypad, and also I want to jump to the LCD, because this will be the coming week. Next week lab is the next week lab. We're gonna use switches, LEDs, RGB. Okay. So, but the week after is going to be about the keypad and LCD. Okay. So now I'm going to teach the keypad. So look here, guys. As you see here, we have one keypad here. As you see, keypad. This keypad, it has 16 switches, right? 4 times 4. 1, 2, 3, 4. 1, 2, 3, 4. So we have 16 switches here. The keypad. Okay. For sure, the keypad is input device. For sure, it's input device to read from the keypad. So number one, I'm going to teach how the keypad is connected and how it works, how the keypad works. I'm going to tell you how, okay? So it's easy. So number one, how it is connected is connected to port A. It is connected to port A. How? So port A, we have 8 pins on port A. We're going to use all of them. So we have here a port A0, 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to use the whole port A. It has 8 pins. We're going to use all of them to connect the keypad. Okay, number one, how the keypad is connected and how I can use it. I'm going to tell you how it is connected. Look at the idea. It's a very, very interesting idea. Look how it works. Very interesting. I love it. Look here. The way it is connected, guys, you can see here, we have wire. This is like a conductor or wire, whatever you want to call it. So we have a wire this way, and we have 4 wires this way, as you see, and we have 4 wires this way. Okay, so we have 4 and 4, right? But every intersection here is not connected. So every intersection is not electrically connected. You got what I'm saying? So it's like sometimes we do this way, sometimes we make something like temperature like this one. So anyway, so we have here 4 wires this way, 1, 2, 3, 4, and then we have another 4 wires this way. Okay. Number one, every intersection here, it is not connected electrically. It's not connected. Is that okay? This is number one. Number two, in every intersection, we put a switch here, a push button here. In every intersection, we put a switch or a push button. Okay, a push button here in every intersection. Push button. You know what is the difference between push button and the switch? Right? I'm going to tell you what is the difference. It is similar. The difference between the switch we have here, for example, this switch. Okay, when I connect this way, I turn everything on. And it's going to continue on forever, right? Until I change it. So when I change it in, I'm going to turn it on, right? And it's going to stay this way, right? But the push button is similar to the doorbell. So when I press, okay, you are going to connect. When you release, it's going to disconnect. You get what I'm saying? So it's only connected when I press, okay? So anyway, so here, they put here one switch for in every connection. Is that okay? Push button, push button. That means, as you see here, guys, that means when I press this button, I'm gonna connect one column by one row. When you press, you connect one column by one row because they are not connected. Unless you press, you connect. You got what I'm saying? So let me say it again. So the way this keypad, this keypad, it has 4 wires, as you see here, guys. This way, 4 wires. These 4 wires are column. I'm gonna call them like you have 4 column here. They are connected to 4 pins, PE0, PE1, PE2, PE3, as you see here. Okay. We also have another 4 row. I'm gonna call them row. So I have row 0, row 1, row 2, row 3. I have column 0, column 1, column 2, and column 3. Again, here they are not electrically connected. However, in every intersection, we put a push button here. Okay, so that when I press the button, I'm gonna make a short circuit. Okay, when I press a button, I'm gonna make a short circuit between row and column. And all what, okay, I'm gonna come to you. And all what I wanna know, okay, now I wanna write a program to figure out which switch is connected. This one or this one or this one or this one, which switch is connected. Okay, you can see here, guys, every switch has a unique pair of row and column. Every switch has a unique pair of row and column. So I need to search, I need to look for which pair of row and column is connected. And by this way, I can know which switch. So if I press this switch, if you press this one, so he actually row 0, column 0 connected. Anyway, what's your question?
It's kind of about what you just said. How does like the output pins tell which input pin is connected to? Do the input pins have like different values that they're sending?
Yeah, I'm gonna explain. That's a good question. I'm gonna explain. So your question here, why I have 4 output and 4 input? Is that your question?
No.
Oh.
My question is, so like, does the input pin 3 just send it like you'll have 3 over it? So if you press A, 4 would be like, yeah, you just received 3, so I got an A.
Yeah, but look here. So this is row 0, row 1, row 2, row 3. This is column 0, column 1, column 2, and column 3. So I need to search. If I found column 0 connected to row 0, that means it's switch number 1, right? If I find 0 with 1, so it is 4. So every switch has a unique pair. If I find the connection is here somewhere, so it should be one of these. I don't know which one. You get what I'm saying? If I know the connection is here somewhere, so it has to be one of these. Which one can tell me? I have to know which row can tell you. Anyway, I'm gonna explain it how it works in details. Don't worry about it. So, but the idea is that again, I have this wire and this is another wire, and they are not connected. However, there is a switch. When I press the switch, I'm gonna electrically connect them together. And in order to know which key you are pressing, in order to know which key you are pressing, I need to know which row is connected to which column. How? That's what I'm going to teach next time.